And the simplest way during the test is just splitting it up, splitting the shaded regions up and finding the area of each region. So we're gonna first split up the star into triangles. These triangles that are one by one, um, one by one, and there are 8 of them. 2 of them on each side. And then we have this center region that's a square and it's 2 by 2. And now we're going to find the area of this shaded region, these 2 shaded parts and regions. Okay, so for the triangles, the area of each triangle is 1 times 1 divided by 2, because to find the area of the triangle, the legs times the leg divided by 2. Leg 1 times leg 2 divided by 2, and we have 8 of these triangles. So that is a total of 4. So 4 is the area of the triangles, and for the square in the center, it's 2 by 2, and it also has an area of 4. And there's only 1 square, so we only have to count that once. So 4 plus 4 is 8. That's the total area of the shaded region, and it's asking for the percentage of the entire 4x4 grid. So the 4x4 grid obviously just has an area of 16. 4 times 4 is equal to 16. So it's asking the percent. That's 50% because it's 8 over 16, which is 1/2 or 50%. Now we're going to move on to problem 2. So as you see, we are presented with a combination of hieroglyphics, and we have a table showing what each hieroglyphic is worth. And we're going to start with the largest on the left. So the largest on the left is this eye looking thing, and we can find it on the table, and it's worth 10,000. So we can write 10,000, and we can move on to the second one and not worry about the first one, because the first one's now worth 10,000. So that's going to add up to the total amount in the future. Okay, so we have 4 of this type of hieroglyphic, which is worth 100, as shown in the chart. So we have 4 times 100, which is the amount each one is worth. And now we're going to move on to the third type of hieroglyphic. So the third type of hieroglyphic, there's 2 of them, and they're each worth 10, as shown in the chart again. So total, they're worth 20. And now we're going to move on to the last and final type of hieroglyphic, and there are 3 of them, and they're each worth 1. So basically, they have a total sum of 3. And we can see if we did it right, because in the number 32, if we use the same method in finding, if we didn't know that the number 32 is represented, we can use the same method and see if we are correct. And there's 3 that are worth 10, 2 that are worth 1, and that has a sum of 32. So it's basically like counting in base 10, where we have what each one's worth. And let's just bring up an example, 432. We can rewrite this as 400 plus 30 plus 2. And we can write this 400 as 4 times 100. We can rewrite this 30 as 3 times 10. And we can rewrite this 2 as 2 times 1. And again, they're just basically like these hieroglyphics. They're worth one amount, and they add up to the total sum. So we can just add up and find the sum right here, and we'll get 10,000 423. So the answer to this problem is going to be B. We're going to start by analyzing the problem. It reads, so this is the most important part. When Annika and 3 of her friends, so that means there's 4 players in the card game, 3 and Annika, 3 and Annika makes 4. Each player is dealt 15 cards. So there's no cards remaining, and they're distributed evenly. So there's 15 cards to each of the 4 players. So each player has 15 cards. That means 60. There's 60 cards in total, which means that this card game has 60 cards that can be dealt to the players. Suppose 2 more friends join the next game. So adding on to the 4 that are already there, there's 2 more in the next game, making there 6, making the total 6. There's 6 players the next game, and there's 60 cards still. There's still 60 cards to deal, and how many cards will be dealt to each player? Since there's 60 cards and there's 6 players each, if we divide evenly, 60 divided by 6, there will be 10 cards given to each player, making the answer C. So he starts with 100 and he counts backwards, and the problem already gives you the first 3 numbers. There's 2 ways of doing this. One is using brute force and just counting it manually and just going backwards by 7 and just listing all of them until you get the 10th number. We can do that, and honestly, if I was doing this during the test, I would probably use this method because it's simple and quick. And if you don't know the formula to solving this problem, then it makes your life much more difficult. Okay, so we're just gonna count backwards by 7s, and we'll get eventually. And obviously your calculations have to be quick because you only have 40 minutes to solve all these problems. So you will get 37 after for your 10th number. You'll get 37, and obviously there is a risk factor for doing this. If you're doing it really quickly, you might count wrong, which is pretty bad, but there is an answer choice for 37, so the answer choice is B. But I'll show you a different method. So the different method is just using a formula, and it's the arithmetic sequence formula. So we start with 100, and the difference is -7 between the first and second and third, and each term after that. The difference is -7. So D is equal to -7. Now since 100 is first term, there's 9 terms after that, and if we see an example, let's just say 193. This is the first number. This is the second number. And from the first and second, there's one difference. We have to add. There's one difference in between them, which is just -7. If we add -7 to 100, we get 93. And if we want to go all the way up to this 10th number, which is x, we have to add how many differences. So between 1 and 2, there's one difference, and between 1 and 10, there should be 9 differences, because if we see 2 minus 1 is 1, 10 minus 2 minus 1 is 1, and there's one difference, and 10 minus 1 is 9, so there should be 9 differences for it to be parallel. So since there are 9 differences, we multiply -7 by 9, we get -63. -63. And we just add it to 100 to find the answer, which is 37 as well. So we did 2 different ways, and we got the same answer, so we know we are correct. The answer choice is the answer to this problem is B. Now we're going to move on to the final problem for this video, and it's going to be problem 5. Now we're going to move on to problem 5. So she starts at F, and she's trying to find the shortest distance. So she first drives to location A. The shortest distance from F to A is 3 blocks, and this is just using some common knowledge here. We're not we're trying to find the most efficient route, and by doing so, we don't loop around and drive elsewhere that we don't need to. And the most efficient is just going down 2 and right 1 for a total of 3 blocks. And we can use the same method from A to B. So from A to B, we're going down 3 and left 7 for a total of, I believe, 10 blocks. And once again, we're not looping around like this. We're just going straight to the target and going, having our mind on the target and just driving toward that target. So once again, 3 down, 7 to the left. Okay, now from B to C, pretty self-explanatory again. We just go up 4 and right 2 for a total of 6. And from C to, I believe, F, we go up 1 and right 4 for a total of 5 blocks. And we just add this up to find the shortest distance in blocks, and that equals 9 plus 19. Oh, no, 15, sorry, for a total of 24 blocks.